Remember, it's easier to glue the actual paper before putting it in your notebook. That way you don't accidentally glue pages of your notes together. All right. There's 2 people there right now. Oh, here we go. We're going to start with inductive reasoning. Inductive reasoning actually goes back to 2-1. So can someone or a couple of us flip back to your 2-1 notes? It should be the first word in 2-1. We also did a glue in. Nope. Inductive reasoning. From 2-1. Well, keep going. That was 2-3, part 1. Oh, yeah. Inductive reasoning. Look at the top sentence. Oh, my gosh. All right, so if you look back at 2-1, inductive reasoning is what? It uses patterns to make conclusions. Okay, so we do this a lot in real life. We use patterns to make conclusions a lot. Okay. What are some patterns that you notice in real life that help you make decisions? How did you decide what to wear today? The weather. Did any of you actually look up the weather and then decide what to wear? No. You looked at stepped out in September. What do you know you're probably going to wear to school?
Pants.
Probably pants. Maybe it's going to be cold out. Is it a rule somewhere it's written down in the United States laws that say in September it's going to be cold? No. That's just a pattern. All right, so for example, in September, the weather is probably 60s. Or in October. It's almost October, I guess. Okay, so we use those patterns to make conclusions. If I say imagine December, imagine it's December 14th. What are some things that you can maybe assume about December 14th without it actually being December 14th? There might be snow. It might be a little cold out. Okay? If I told you what might you be wearing on December 14th, or if I ask you that, what might you wear on December 14th? Long sleeves. If you're outside, you'd probably wear a coat, right? Mittens, maybe. Okay, that's based on patterns, based on your experiences of December. All right, so that was inductive reasoning. We see that prefix in. Today we're going to be talking about deductive reasoning. Deductive reasoning uses rules, laws, and properties. When we talk about properties, we're going to talk about math properties, not like the property you own. Okay, rules, laws, and properties to make conclusions. All right. So for example, if you go 5 miles per hour, that means we're driving. We're going 95 miles per hour in a school zone. Then, those of you that have taken driver's ed, already have your license or your permit. If you go 95 miles per hour in a school zone, what's probably going to happen? Maybe jail, but for sure you're going to get a ticket.
That's like way over. That's like 30 over.
It is like 30. It's more than 30.
Yeah.
Because the school zone is probably like 30 miles an hour, right?
Yeah, because how much is a school zone? Like usually mile per hour? 30.
And if children are
So 95. Yeah, so especially if children are present, you'd get a ticket. There is no way you're going to talk yourself out of that one. Okay? But that's based on a law. Speed zones, speed limits are laws. That's how we decide whether or not you go to jail, things like that. Alright. So we're going to do 2 laws today in math. A law in math is something that we don't necessarily prove. We can show why it works, but we know it's a fact. It's a law. It's something that we can go by. It's something we can use. Okay? So law of detachment. With law of detachment, we're going to be deciding with if-then statements. So if we are given that if A happens, then B happens. So we know that A will lead to B. Is your e-hop pass working? Okay. Did you check your pen? Okay, mine is not working. Alright. If A, then B. And then we know that A happened. Okay, so for example, if I say, if everyone shows up to geometry on time, I'll give you all a Jolly Rancher. Okay, we're 5 minutes into class, and you noticed everyone came to class on time. What do you assume? You get a Jolly Rancher, right? Has it happened yet? No. But you would assume that. So if A happened, that's going to lead us to conclude that B will happen or that B already happened. Yep. Crushing it. It's working on this one. Don't know. Okay. Give me 1 second. Sorry. That whole mistake. No. While this is happening, go ahead and grab out your pencils. We're going to use like 4 to 5 colors today. You're probably going to need to share colors, so maybe just grab out the whole bag. They should be in that pencil bag. There we go. A happened. We can conclude that B will happen, or perhaps that B already happened. Okay. I'm going to use red and green. So my hypothesis is A. What is my conclusion? B. So if I know my hypothesis A happened, then I can conclude B. So this is kind of like a first this, then this, chronological order. Okay, so we're going to decide if we can make some conclusions here, or if the conclusions that the person made are valid or invalid. Okay, valid is kind of like that true, yep, it works. Invalid means it does not work, it's false, it can't happen, or we can't make that decision. Okay, I'm going to zoom in a little bit. All right, the first one we know, if Miss Morel wakes up late, then she is cranky. Abdi notices Miss Morel is cranky, so he assumes she probably woke up late. So let's start by breaking apart our hypothesis and conclusion. What's our hypothesis? If Miss Morel wakes up late.
Usually it's probably that word if.
What's our conclusion? What does that lead to? I'm cranky. Okay, so if I wake, that makes me cranky. Okay, what does he know that I woke up late, or does he know that I'm cranky? I am cranky. So is that the hypothesis or the conclusion that he notices I'm cranky?
No. Conclusion.
That was the conclusion of that statement, that Miss Morel is cranky. We're starting with the crankiness.
We're using that same color.
So if I start out with being cranky, can he assume that that means I woke up late?
Is it possible that that's the reason? Can you think of a counter example? Is there another reason she might?
You're hungry.
I'm hungry.
Hungry.
That's always a good one. I'm hungry. Have any of you dealt with me when I'm cranky?
Yeah.
Oh, Destiny's saying no. That's so cute.
Cranky.
Have I been cranky before? Is it always because I wake up late? No.
You're stressed.
Sometimes when I'm stressed out, sometimes my husband just makes me upset. Sometimes I'm just cranky, right? Feel your feels. Okay, so we cannot work backwards. That is not how that works.
Okay, so remember, we're going to use that word valid. Valid would be like true, or invalid would be like false. So would we want to say that this is valid or invalid?
Invalid, because I'm starting with that conclusion and then working backwards. What would be a counter example? She could be hungry. I get very cranky when I'm hungry. If I had walked into class and told Abdi, hey, I woke up really late, then Abdi could be like, okay, she's probably cranky today. I'm going to be really nice to Miss Morel. Okay? But because I'm already cranky, he can't go back and say, oh, that must mean she woke up late. It might be that I woke up late, but there could be lots of other reasons. All right, next one. If two angles are vertical, then they are congruent. Destiny notices angle A and angle B are vertical, and she assumes angle A, what's that symbol again? Congruent, it's equal, but we want to specifically say congruent to angle B. All right. What is our hypothesis in our conditional statement in that first sentence? Okay, two angles are vertical. So I know vertical leads to what? They are congruent. I'm going to use that little symbol for congruent. So if I know two angles are vertical, they're across from each other, that means they are congruent. Okay? We're assuming that that's true now. That's a fact. It is a fact. Destiny notices angle A and angle B are vertical. Did she notice that the hypothesis was true or the conclusion? She starts by noticing the hypothesis. Angle A and angle B are vertical. So she assumes what? She assumes that they're congruent. Does it follow that pattern? Red leads to green. So red happened. Does that mean green will happen? Yep. So it goes in that same order. A leads to B, A to green. What? Our papers aren't the same.
It says versus angle A and B, comma, she assumes angle A congruent angle E. It doesn't say a vertical.
Why? Okay, well that's silly. Okay, if yours doesn't say vertical, maybe sneak that word in there. Sorry. Some people it just says notices angle A and angle B. Sneak in that word vertical. Are vertical. Sorry. Okay, wait, let me see yours. Why is it? So weird. Okay, don't know. So sneak in that word vertical if you need to. She notices angle A and angle B are vertical. Okay, can she assume that they're congruent if she knows they're vertical? Yep, that's what it tells us. It says if they're vertical, then they're congruent. And she says, yep, they're vertical. So she can say, yep, they're congruent. It goes in that direction. So is this going to be valid or invalid? Valid, good. Okay, now parents use this law of detachment a lot, especially if they're thinking about things that their kids want. Okay, or if we think about that mouse. A mouse asks me for a cookie. I'm going to assume, okay, if I give him a cookie, what else do I need at home? I need milk. If I'm out of milk, should I give that mouse a cookie? No. So I don't have milk to give him. If I give him a cookie, he's going to want milk. And then he's going to have a meltdown, and he's going to cry, and it's just going to be a whole thing, an all-day thing. Well, maybe I can distract him with some, like, goldfish. Because you don't need milk when you eat goldfish. It's a snack that's goldfish. All right. Last syllogism.
That was so bad.
You're so bad.
Okay.
Okay, last syllogism. This is a really weird word. It's syllogism. Syllogism. I don't know, man. All right, last syllogism is, we're going to use some other colors when we do this, but we'll get there. Okay, we know that if G happens, or if G, then H, and we know if H, then K. So I'm going to use 3 colors this time. I'm going to switch up my colors a little bit. I'm going to use purple and yellow. If you want to switch colors, you can, just because we're doing a different law. This law is going to allow us to create a new conclusion.
You could be using any letters here, any variable instead of
Yellow, purple, and pink.
one thing happens, then it leads to another. If that happens, it leads to another.
Okay, and this is really where that if you give a mouse cookie happens, because if you give a mouse cookie, it leads to milk, milk leads to straw, straw leads to napkin. Okay, code it. I'm going to do my G in yellow. If G leads to H, and then it picks up right where we left off, that H now leads to K. That was a little dark, sorry. Okay, so G leads to H, but we know that H will lead to K. This is kind of like that domino effect. this happens, and this happens, and then this happens, and this happens. What? Cool. We have 30 seconds, so we're going to finish this after lunch. So, okay, so G leads to H. H leads to K. That's based on one of your protected classes. Alright, here we go. If G leads to H and H leads to K, so if I give a mouse a cookie, eventually the mouse will want milk. If you give him milk, he'll want a straw. If he gets a straw, he gets a napkin. Could I say if I give a mouse a cookie that eventually he's going to want to cut his hair? Yeah. Are we going to get there eventually? Yeah. So that's like this. If G leads to H, and then that H leads to K, that domino effect is going to allow us to skip from G to K, because that middle part is the same. So we can conclude, we can write a new sentence, a new conditional. If G happens, then eventually what will happen? K.
Alright, we're going to go through 2 examples, so make sure you find your same colors you were using.
Alright, so for our first one it says, if Miss Sawyer has a good day at school, then she'll give her kids ice cream. If Miss Sawyer have ice cream, then they will be pumped. You're so excited. So first one, what is our first hypothesis? What is the start of all of this? Miss Sawyer has a good day at school. If she has a good day at school, what happens then? She'll give her kids ice cream. Alright, so that's our first conditional statement.
Oh. Someone's wrong.
Yeah, that's my stomach. Alright, if Miss Snyder's kids have ice cream, then they will be pumped. So, does it start the same way we left it off?
Oh, yeah.
Yeah, she'll give her kids ice cream. If Sawyer gives kids have ice cream, so they get ice cream, so it's the same color, then they will be pumped. Conclusion, can I write a new conditional? If Miss Sawyer has a good day at school, eventually happen. The kids will be pumped. They love it when Miss Sawyer has a good day at school, because then they get ice cream. But we aren't going to write that ice cream part. So we're going to write, if Miss Sawyer has a good day at school, and this is why I glued mine in, because I'm going to run out of space because I write big. If Miss Sawyer has a good day at school, then what? Kids will be pumped.
And can we assume that they're going to get in between there? Yeah, but we don't have to write that. We can jump right from G to K. We're going to assume that they get ice cream, and that's why they're pumped.
So it starts with that first hypothesis. It starts with that if Miss Sawyer has a good day at school, which was my yellow. And yellow led to pink, and pink lead to my purple. But you might have it different colors, so do your colors. Trying to keep it light, because when I color it dark, it's hard to see, sorry. Whoa.
All right, we're going to make a couple little changes to the next one, so watch really closely as we go through this. We found a mistake we had to fix.
If you study for the test, then you will receive a high grade. We're going to cross off this part. Okay, so if you study for the test, then you will receive a grade. If you stay up late before the test, if you stay up late before the test, then you will get a low grade. Oh, that's not the right word. If you study for the test, you'll receive a high grade. If you stay up late before the test, then you'll get a low grade. Alright, so what's our first sentence? What's our first starter? Yes, you study for the test. Then what? You'll receive a high grade. If you stay up late before, do either of those have a connection at all? It's connected. Is it like a domino effect though, that if you study, no. Study leading to a high grade, which will lead you to, we don't know, right? Doesn't tell us. So in this case, because these are different, if you want to use your other colors, you could. So yellow leads to pink, orange leads to green. Do we have anything where it like has that overlap? There's no overlap here, so can I determine what kind of grade you're going to get on your test? No, I don't right now. I don't know because I don't know if you studied. I don't know if you stayed up late. So in this case, there is no valid conclusion. Which means that it's not necessarily false, these statements. It's just that we can't come up with anything else. That's the information we know. There's not anything else that we can come up with that feels new or looks new.